Well, hello one and all, and welcome to our short on the random module. Now, the random module is a module you can use to add an element of randomness or chance to your programs. And we'll see here, I have a program called cards.py, which I've created by typing code cards.py and adding in these lines of code on lines 1, 3, 4, and 7 down here. So the goal of cards.py is to simulate kind of dealing from this deck of cards that I have here in the form of this list, one called cards with 3 cards, Jack, Queen, and King. But if I want to deal cards, I could think of this element of randomness, shuffling the cards and dealing them and seeing what cards I get. And to get some randomness, well, I need to use the random module. So I can import it up top using import random, just like this. And then down below, I can see a few ways to use the random module with a few functions that are built into it. Now, one we've seen is the choice function, which I can get access to by calling random.choice. And .choice here, this function, takes as input some list and returns to me some random element from that list. So I think I could give as input here cards, my list, my deck of cards here, and have it choose for me one card randomly from this deck of 3. I could then print the result just like this. If I go down below and type Python of cards.py, we'll see I got back Queen from random.choice. Just to prove this is a bit random here, I'll do Python of cards.py, and I get Queen again by chance, but let's keep trying. I'll get Queen again. I'll do Python of cards.py, and there we go. Now we have a new card, again, each one being chosen randomly by chance. So what else is built into the random module? Well, one that can be useful to you, one function, is not just choice, but choices, plural. And choices, true to its name, lets you choose not just one item from a list, but multiple if you want to. So let's try that out. I'll go down below and I'll type random.choices. And it turns out, if I read the documentation, I'll find out that choices, this function, takes as input, its first argument, the same list of options to choose from. And the second argument is one called k, which stands in for the number of items I want to randomly choose from this list. So here, let's try choosing 2 cards instead of just 1. I'll set k equal to 2. And now, if I go down below and run Python of cards.py, let's see what we get. I'll get queen and king. So it seems like I randomly chose 2 cards from this deck and got back queen and king. Let's keep trying this again. I'll do Python of cards.py. I'll get queen and jack, Python of cards.py, king and jack. And we can keep going here, but so here I seem to have gotten queen and queen, which might not be what you'd expect. Now it turns out that random.choices is doing what's called sampling with replacement. It's akin to me having a deck of 3, shuffling it, taking 1 card out, writing down that card, putting it back in, shuffling again, and choosing another random card from that same deck of 3. So every time I choose a new card, in this case, I'm choosing from this set of 3. When I choose a card, that doesn't eliminate it from future choosings of my random choosing in this particular case. So this is sampling without, or sampling with replacement, adding the card, let's say, back into the deck. Now, if we don't want that, we want to sample, let's say, without replacement, I could use a different function, one called random.sample, and this one has the same arguments, the first one being the list of cards to choose from, or really any list to choose anything from, and then k being the number of items we hope to select from this list. Now, like I said, random.sample will select with replacement. It's without replacement. It will be akin to me having this deck of 3, shuffling it, taking 1 card out, shuffling the remaining 2, and choosing 1 more card. So let's see what happens here. I'll run Python of cards.py, and I'll get back queen and king, 2 distinct cards. I'll again do Python of cards.py, jack and king, and again queen and king. So you can see here I'm getting a random set of choices from this deck, but because I only have 1 card for each, in this case, jack, queen, and king, I'll always get, at the end, unique choices from my deck. I'm here sampling without replacement. Now, what if I wanted to maybe weight the odds a little more in my favor and make some things more likely to happen than others? Well, I can actually use, if we go back to random.choices, another argument to this choices function, one called weights. And weights takes as input, this argument here, a list of values, numbers to be sure, the same length as the list that I'm selecting elements from. So let's say I wanted to, currently make it more likely a user will choose the jack card. Well, I could do that by adjusting the weights here. Currently, if I didn't set weights at all, it would be equally likely that a user would choose jack, queen, or king. But I could weight things more, let's say, in my favor, and maybe make it so that the user 100% of the time will choose jack. And I can do so like this. Here, 100, kind of indicating 100%, means that the user will always choose the jack card, and 0 here, meaning kind of 0%, will be they'll never choose, in this case, queen or king. So let's run this. I'll do Python of cards.py, and here, well, unsurprisingly, we get jack, and we'll run this again, get jack, and again, get jack and jack. So it seems like I've weighted things more towards this jack card. But what else could I try? Maybe I could make it only a little bit more likely that a user chooses the jack card, and I'll then make it a little more likely they choose the queen card, and king, let's put it about 5%. So to be sure, these weights add up to 100%. Of course, we're always going to select at least 1 card from the options here. But it seems like 75% of the time we'll get back a jack, 20% of the time we'll get back a queen, and 5% of the time we'll get back a king. So let's try this out. I'll run Python of cards.py, again get jack, Python of cards.py, again get jack. And if we keep going, odds are we'll eventually, as we have down below, end up with a queen. But again, this is much less likely than it was before without having applied these weights. Now, randomness is really fun, really cool, but it's not so fun and not so cool when you're trying to debug your programs. In fact, randomness can get in the way of debugging because really you want to think of debugging as thinking of defined inputs and defined outputs. And if everything happens randomly, it's hard to debug your program. So thankfully, there are ways to have your programs work with randomness, but to guarantee certain outcomes when you want to do something like debugging. Now, in the random module, there is, in this case, a function called seed. And a seed is something that goes into this thing called a pseudo-random number generator. It actually underlies the random choices that go into functions like choices and sample and choice that we've seen here. Now, it turns out that when you initialize a Python program like this one, or call a function like random.choices, you are using that pseudo-random number generator, and it takes as input something like a seed that might change on different runs of your program, like your system time. But if we give a seed that is a specific number that always stays the same, well, we'll always get the same choices from, let's say, a function, like random.choices or sample or choice. Let's take a look at it here. I'll go down and I will say random.seed, random.seed, and I'll give it here some number. Let's just say 0 for simplicity. Now, normally, the seed would be set by something like my system time. It changes on each run of the program. But here, I want to define it explicitly as 0 every time I run this program. Well, I could go ahead and run Python of cards.py, and we'll see we get back king and king by chance. But now if I run Python of cards.py, I'll get back king and king again. And maybe again here, I'll get back king and king. So it seems like setting the seed has given me a random choice, certainly from this deck, but one that will always stay consistent. And I could try this again. I could do maybe a seed of 1 and see if that might change anything here. Python of cards.py. I'll get jack and king here. And I claim that as long as my seed is 1, I'll get back jack and king. So setting the seed here is a really good way to help you debug your programs. Your programs can involve randomness, but you can actually be sure of the outcome when you set something like a random seed. So this was our short on random. Feel free to use it to add an element of chance or randomness to your programs, or whenever you want to set the odds in your favor. This was our short on random. We'll see you next time.
All right, this is CS50's Introduction to Programming with Python. My name is David Malin, and this is our look at style. Now, up until now, we've been writing code that's hopefully at least correct. That is, the code does what you intend it to do. And hopefully, it's also well designed. That is, you're using relatively few lines of code to achieve some goal while still ensuring that it's readable. You're perhaps using functions that save you the trouble of reinventing wheels, so to speak. But it's possible that your code isn't necessarily manifesting the best style as well, which is another form of quality that you can ascribe to some code. Now, style, or the right type of style to use, is rather subjective, and it depends typically on the programmer, on the company, on the course, or on the language that you're actually using. But within the Python community, it turns out that there's some pretty regimented standards that most all Python programmers adhere to, or are rather expected to adhere to, because this particular language and community has tried to codify some of their preferences for how your code should look in the form of something called PEP 8. So a PEP, or PEP, Python Enhancement Proposal, is a set of proposals that the community within the world of Python typically generate to not only propose new ideas, but also to codify ultimately certain standards. And PEP 8 happens to be such a proposal that standardized, or rather tried to standardize, what our code should look like. That is to say, say it's quite possible to write code that's not only correct, it might even be well designed, but it's just really a mess. And it just doesn't look very good. It's not very pretty. It's therefore harder to read. It's harder for others to read. And therefore, it's just not as maintainable. And anytime you make something harder to read or less maintainable, you're just increasing the probability, dare say, down the line of introducing bugs. So it's a good thing for your code to be properly formatted, just like in the world of writing emails or essays or books or documents or beyond. It tends to be good practice to capitalize certain words, at least in English, use good punctuation, use paragraph breaks and the like. So even if you're relatively new to programming, at least in English or your own human language, odds are you've had quite a bit of practice with writing language in the human world that also just looks good as well. Well, what does it mean to look good in the world of programming code? Well, let me propose that if you look at PEP 8 itself, which is available on the internet via this address here, it turns out that it tries to standardize a number of details that would be manifest in your own code once you've written a number of lines. And the overarching premise of PEP 8, and really the notion of style in the Python community especially, is that, quote unquote, readability counts. And typically languages, Python among them, come with what's generally known as a style guide. A style guide, not unlike PEP 8, is some kind of guide, a document, either printed or perhaps internet-based, that just tries to standardize what everyone's code should look like. So a course that you're taking might have its own style guide. A company you're working for might have its own style guide. You, down the road as a professional programmer, might have your own style guide for your own code, but within the Python community, they've tried generally to standardize, for the most part, a lot of these details. And ultimately, quote unquote, too, a style guide is about consistency. Consistency with this style guide, in the context of Python, is important. Consistency within a project is more important, and consistency within one module or function is the most important. So that is to say, these aren't necessarily hard and fast rules, but rather guidelines that should guide the design of your own code. Now, how do you go about designing, or how do you go about styling your code well? Well, it boils down to things like this and many more. Indentation, using consistent indentation. Now, in some languages, it doesn't strictly have to be there when you indent one line of code under another. Or it could be one space or two spaces, three spaces or four, maybe even 8 or an actual tab. In the world of Python, they tried to put an end to this debate, and they prescribed that we all just agree to use 4 spaces consistently. Tabs versus spaces, no tabs. Spaces instead. And indeed, typically in something like VS Code, when you hit tab on your keyboard, depending on how the program is configured, it should generally convert even things like tabs to individual spaces like 4. What about maximum line length? Your code tends to get less and less readable the longer and longer your lines of code get, especially if they start to scroll over the screen. So Python 2 tries to standardize what the maximum line length is. You just shouldn't go past a certain number of characters to the right of your screen. Blank lines, using some number of blank lines, for instance, between blocks of code, perhaps among comments, also just lends itself to making your code more readable. Why? Because it's not just a wall of text, a wall of code that you or other programmers have to see. By adding in blank lines and white space more generally, it can make it a little easier to wrap your mind around what's going on. And then imports, even something like this, when you're importing this library or that, or this module or package, Python 2 prescribes just how and where you should generally put those lines of code that say import or from, and Python via PEP8 also prescribes any number of details as well. And these aren't details that we necessarily preach along the way, but rather practice as we write each of these examples in class. And it turns out, too, that as you see more and more code, well, you just get accustomed to the certain rules of proposals like these. So how do you go about, though, checking if your code is in conformance with something like PEP 8 or a style guide more generally? Well, you can certainly read the style guide itself and then look at your own code and compare the two left and right and decide, oh, I need to fix this and this other thing in my own code. But there's also tools, being programmers, that can help us solve these problems as well. And one of the most popular in the world of Python is a program called PyLint, which is an example of what's generally known as a linter, which is a program that rather statically analyzes, that is, reads your code top to bottom, left to right, and tries to figure out if there are potentially mistakes therein, or at least inconsistencies with something like a prescribed style guide. This is something that you can install via the usual ways, using something like pip, and its documentation is here. But it turns out there's other tools out there as well that are perhaps a little less noisy than PyLint. It turns out if you run PyLint on most of the programs you've written thus far, odds are you're going to be overwhelmed with just how many things you apparently did wrong stylistically, even though your code may very well be both correct and well designed. So a little less noisy, at least initially, might be this program here that's the de facto standard within the Python community for formatting your code for you. PyCodeStyle, formerly known as PEP 8, a program as well, is a program that you can not only run on your computer, documented at this URL here. It will actually take care of the process of reformatting your code for you if it's a bit messy. That is, if the style of your code, your indentation and blank lines and other details as well are not in accordance with the style guide, something like PyCodeStyle will just fix it for you. But another one, an alternative nowadays that's actually gaining steam, is perhaps even more popular nowadays, quite simply called Black. And Black is a program that you too can install with pip here, and it's documented at this URL. And the etymology of the name Black is actually an allusion to Henry Ford, who invented cars way back when and only sold quite a few black models of the same. And indeed, he's generally known as saying a quote along these lines: "Any customer can have a car painted any color that he wants, so long that it is black." So if you think about that for a moment, it's not quite a choice. And indeed, that's the spirit of this particular formatter called Black, which is that it's opinionated more so than others. With a lot of these formatters that exist out there, you tend to, or your company tends to, or your course tends to configure them with certain rules. So there might be different ways to do indentation. There might be different ways to do imports or blank lines. And different companies and different people might reasonably disagree and therefore have their own style guide here, their own style guide there. And it just tends to waste a lot of time, is the thinking, if all of us don't even agree on some of these basics. So this particular formatter called Black is opinionated in the sense that it just makes a lot of these decisions for you. And if you don't like the way Black is formatting your code, tough. That's the way it's going to do it. And this is a trend perhaps now, at least within the Python community, of quibbling a little less over these stylistic details so that you and I can ultimately focus all the more on writing good code and solving actual problems. And let's go ahead and do just this. Let me go ahead and open up VS Code here, where in advance I've created a program called students.py, whose purpose in life is just to create at the top of this program a dictionary containing key value pairs, the keys of which are the names of some students, the values of which are the houses at Hogwarts in which they live. And then I've just got a for loop here that iterates over each of those students, printing out for now each of their names. You could imagine certainly doing more with the values as well, but for now, this is a simple program, but it's already manifesting poor style, arguably, certainly inconsistent with PEP 8 itself. And I know this from just experience, eyeballing it and realizing, wow, this is not a good thing that this first line of code goes completely off my own screen. Feels like it's probably a little long, and I'm going to have to scroll to even see what's going on. And this one's more subtle, but if you look at line 3 here, even though I've indented technically sufficiently, so long as my code is indented underneath the for loop, and any subsequent indentation, if I had more lines of code, were similarly indented, the code would work and it would be correct, but it just does not accord with PEP 8, which prescribes, again, 4 spaces of indentation at each level. So how can I go about fixing this? Well, if I've already installed one of these formatters, for instance, something like Black, I could literally just do this with my terminal window. I'm going to run the command black space students.py and hit enter. And voila, you'll see that the students.py file has been automatically reformatted. And at the top of my file, I have now a dictionary. Same dictionary as before, but just so much more readable. Not only does it not wrap around to the edge of the screen, you can also see each of the key values pairs one line at a time. And you can see that it lends itself to even adding more down the road. It turns out it's not incorrect to have a final trailing comma like this, even though it's not strictly necessary here on the new line 6. Why? Well, Padma in Ravenclaw is the very last student in this particular dictionary, but just in case, as is often the case, I might go in and start adding more key value pairs later. A common source of mistake is to accidentally forget that, oh, I didn't have a comma there previously, and here I am adding more key value pairs. So that is the kind of detail that Black not only fixes for you, but again has an opinion on as well. So moving forward, as you write code of your own, it's good to get ingrained into some of the lessons of and some of the guidelines in a style guide like PEP8, but know that there's tools, be it PyCode Style or Black or something else altogether, that you can use as a programmer to help you focus more on correctness, more on design, more on solving actual problems, while still ensuring that your code is now automatically formatted as well.